Good evening. I hope I am audible.
Yes, sir.
Yeah. Okay. So can you just solve this? Okay. Now tell me how many decision variables are there in this problem?
Sir, is it 9, sir?
Correct. So it is 9. Okay. So you have 3 crops is given. So you have 3 crops is given. Sugar beet is given. Cotton is given. Sorghum is given. And it has to be cultivated in all the 3 places. All the 3 crops you need to cultivate it in all the 3 places. So the quantity of sugar beet whatever you are cultivating in place 1, that will be your x1. Same way, the cotton, whatever you are cultivating in place 1, that will be your x2. Same way, the sorghum that you are cultivating in place 1, that will be x3. Likewise, you will have x1 to x3. Same way, x4 to x6 and x7 to x9. So there will be totally 9 decision variables will be there for this particular problem. Okay. So the decision variables will be, so it will be based on crop and it will be based on place. So you will have sugar beet, you will have cotton, and you will have sorghum. So place you will have 1, 2 and 3. So it will be x1, x2, x3, x4, x5, x6, x7, x8, x9. Is that correct? Are you getting to it? Any doubt in this? Any doubt in this? Now, any doubt?
No, sir.
Yeah. Now tell me what is objective function is. Now, what is the objective function is?
Maximizing the profit or return.
Yeah. So what is where is the profit data given? So profit data is given over here. So by cultivating sugar beets, you will get a net return of rupees 1000 per acre. Cotton is 750 and sorghum is 250. Now, can you just formulate it? Can you just formulate it? Objective function, can you formulate it? So this return is given as 1000. This is given as 750. This is given as 250. So objective function is to maximize. So maximize z equals 1000 into x1 plus x2 plus x3 plus 750 into x4 plus x5 plus x6 plus 250 into x7 plus x8 plus x9. 9. Clear? Is it correct? Now tell me the constraints.
The water consumption
Okay.
for each places.
Okay. Then
Usable land, sir.
yeah, okay. So
Like
under water allocation, how many constraints will come?
3. So total 9.
Yeah, this is 3. This is another 3. Okay. Then another 3 is over here. Maximum quota. And fourth set of constraints is here. Same proportion of its available irrigable land. So there will be totally 12 constraints will be there. Okay. There will be 12 constraints plus 1 non-negativity. Can you just formulate it? Can you just formulate it? I think the problem is there with you. I'll just show you the decision variable so you can correctly formulate it. Constraints, usable land. Okay, so usable land, how the constraint will come? So usable land in what condition is given? Place 1 is given. Am I right?
X1, X4, X7 should take.
Yeah, exactly. So the usable land constraints will be something like this. It will be x1 plus x4 plus x7 less than or equal to 400. Yeah, same way x2 plus x5 plus x8 less than or equal to 600. Same way x3 plus x6 plus x9 less than or equal to 300. Now water allocation. How will be the water allocation?
3x1 plus 2x4 plus
Yeah.
x7 is less than or equal to 600.
Yeah, correct. So it is 3x1 plus
2x4
x4 plus x7 less than or equal to 600. 3x2 plus 2x5 plus x8 less than or equal to 800. 3x3 plus 2x6 plus x9 less than or equal to 375. Right. Now the next set. Total acreage for each crop.
x1 plus x2 plus x3 less than or equal to 600.
Yeah, correct. Total acreage for each crop. That is x1 plus x2 plus x3 less than or equal to 600. Then x4 plus x5 plus x6 less than or equal to 500. x7 plus x8 plus x9 less than or equal to 325. Yeah, then what else?
Non-negativity of all.
No, one more constraint is there. One more set of constraint is there. So you can see same proportion of its available irrigable land that you have not solved. Okay.
X1 plus x4 plus x7 by 600 is equal to x2 plus x5 plus x8 by 800 is equal to
800, it is 400, 600
sorry,
is
yeah,
given.
sorry, 400, 600,
Right.
300.
Right. So equal proportion of land. x1 plus x4 plus x7 divided by 400 equals x2 plus x5 plus x8 by 600. Same way, x2 plus x5 plus x8 divided by 400, sorry, divided by 600. Equals x3 plus x6 plus x9 divided by 300, and last one x3 plus x6 plus x9 divided by 300 equals x1 plus x4 plus x7 by 400. So you can convert all this. Okay, you can convert all this. The first one, if you convert it, it will be 3 into x1 plus x4 plus x7 minus 2 into x2 plus x5 plus x8 equals 0. That's the way you can convert. This is only the first equation I have converted like this. The other equations also you can convert. And finally, you can write all xj greater than or equal to 0. J varies from, okay, j varies from 1 to up to 9. I'll just share you this PowerPoint like this. Okay, so previous all problems, what all the problems we have solved, whatever I have solved it in the board, I just copied and paste like this. So every problem will be continued by its formulation, and whatever is solved, that also will be there. So this set of slides I will share to you. Okay. So I just completed it. Only this problem I need to add the solution to it. Okay. Is this clear? Tell me the objective, tell me the constraints for this problem.
Sir, like 2000 x1, the 2000 x2 will come, sir, because we are considering kilogram.
Okay. See, units you can ignore. No need to bother about the unit. Okay. So what is the objective? Is it to maximize or to
Sir?
minimize?
Sir,
What is?
it is to maximize the profit, sir.
Minimize.
Oh, the total
Or,
cost is minimum they have given. Sir, actually,
Yeah.
we could solve it in this way, no, sir. Like, we could form a table.
Okay.
Hello, sir.
Yeah,
Where,
you're audible. Carry on.
yeah. Yes, sir. So, having chloride, nitrate, and sulfate as columns, and XY as rows, sir.
Okay.
So, for substance X, they are giving 8 mg chloride, 4 mg nitrate, and 6 mg sulfates. So, we could add it accordingly. Similarly,
Okay.
for Y, we could get 10, 2, 2, sir. So, we would be getting basically like it's like a 2x3 table.
Okay.
Also, they are giving it is request to produce the mixture using substance X and Y, so that the total cost is minimum. So that is we have to like the cost they are using, that cost is minimum, so we could use it minimum Z, no, sir.
Yeah.
20x plus 20y, minimum Z equal to 20x plus 20y.
Okay. Right. So as you told, I just formulated to you for your help. I just formulated to you in the column wise from the data. This is what you expected, lab. Am I right? So you can see the substance. So quantity
Yes, sir.
of decision variables. Yeah, two decision variables, x1 and x2. So substance X as x1, x2 as y. So cost is given, cost per unit is given. Both are 20. Okay, so X contained 8 mg of chloride, 9 mg of nitrate, and 6 mg of sulfide. And Y is also given. Y also contains 10 mg of chloride, 2 mg of nitrate, and 6 mg of sulfate. And minimum requirement, okay, you have to please note it is minimum requirement, not the maximum requirement. Okay. So how will be my, so this will form my objective function. Okay, and these three will form my constraint RHS side. Okay, constraint RHS. Am I right? So constraint RHS, what symbol it will be?
Greater than equal.
greater than
Yeah,
or equal to.
it will be greater than or equal to. Correct. Okay, so I just formulated it. You can just go through the formulation. Okay. You can just take a screenshot of the formulation and solve it this in a graph sheet. Okay, I need the result. Please solve it in a graph sheet for this problem. We will go through the last problem also. Okay, so this will be the last problem. Just go through it, get me the decision variable and get me the objective function. Tell me.
So, okay. So we need maximum profits, sir. So and decision variables will be x1 and x2. Number of ordinary and deluxe models. So we have number of hours is given. So for one day, one person can work in 8 hours. So number of skilled hours is 5 into 8, 40 hours, and semi-skilled would be 80 hours.
Okay.
So for we have also have the requirements. So for deluxe model, you need 2 skill hours and 2 semi-skill hours. For
Okay.
ordinary, you need 1 skilled hour and 3 semi-skilled hours. So you can
Yeah.
have the equations. So for deluxe model, that would be 2x1 would be 2x1 plus 1x 2x1 plus 1x2 is less than or equal to 40, and 2x1 plus 3x2 is less than or equal to 80. So using these two equations, you can plot a graph and find x1, x2.
Okay. Yeah. So as you told it is right. So model, deluxe and ordinary. So that are our decision variables, number of houses to be constructed. So skilled men required is 2 and semi-skilled is 2 in the case of a deluxe home. So you can see over here like this. Okay, ordinary also shown 1 and 3. It is of 800. Okay, the available resource is shown like this 40 hours and 80 hours. Okay, so you are right. So you can formulate it. So profit is to maximize. Okay, profit is to maximize, and resource availability is also given. Yeah. I didn't shown its formulation, so you can formulate it. Yeah, okay. And you can solve this also graphically. So this is x1, this is x2. So how will be the formulation?
Two x1 plus x2 less than equal to 40.
No, tell me first the decision variables for that. Please go as per this thing.
X1 for deluxe and x2 for ordinary.
Yeah. Okay. Number of houses ordinary. Okay. Now objective function.
For question can say
Yeah.
1000 x1 plus 800 x2 is the objective function.
Yeah. So it has to
Maximize.
add. So objective function is to maximize z equals 1000 x1 plus 800 x2. 800 x2 subject to constraints. Yeah, subject to constraints. 2x1 plus x2 less than or equal to 40.
40. Then 2x1 plus 3x1.
2 less than or equal to 40. Next one.
2x1 plus 3x2 less than
3x2
equal to
80. 80. 2x1 plus 3x2 less than or equal to 80. And finally non-negative x1 comma x2 greater than or equal to 0. Okay, so this also you can take a screenshot, plot these two graphs. for this problem and please bring it to the tomorrow's class.
Sir, can you upload the presentation?
Yeah, sure. I can upload the presentation. Okay. So I just need some time to just cut and paste this to the. After that, I'll upload it. Okay.